Exercise about intersection between two non-projecting planes using the Monge's projection method. Let's consider the following exercise. Determine the intersection between two planes, a ramp plane alpha and an oblique plane gamma. Plane alpha is defined by two straight lines R and S that are simultaneously parallel to the frontal and horizontal reference planes. The straight line R has 5 cm of ordinate and 3 cm of elevation, and line S has 2 cm of ordinate and 5 cm of elevation. Plane gamma is defined by its plane traces. Both the frontal and horizontal traces of the plane gamma make 50 degrees to the left with the x-axis. This exercise is solved using the Monge's projection or orthogonal double projection method. It is also provided a 3D auxiliary drawing corresponding to what we are doing in 2D on the left. We start by drawing the x-axis, the intersection of the frontal and horizontal reference planes. To begin an exercise of intersections, we must first think on the result that this intersection will produce. In this case, we have an intersection between two planes that will result in a unique straight line, here designated as high. Given the nature of this intersection, we will further see that we will not need the profile reference plane that establishes the abscisses. First, we draw the straight lines that define alpha, R with 5 cm of ordinate and 3 cm of elevation, and S with 2 cm of ordinate and 5 cm of elevation. These lines can be designated front-horizontal, since they are simultaneously parallel to both reference planes of projection. Plane alpha can now be defined by two straight lines. Remember the property of plane definition. A plane can be defined in three different ways. To define the traces of plane alpha, we need the traces of each line. However, in this special case, counting only on our 2D exercise, the front-horizontal lines do not possess traces, since they never touch the reference projection planes. Thus, we need a third auxiliary line that must also belong to plane alpha. In 3D, we can easily see that plane alpha is a ramp plane, also stated in the data, and then a suitable auxiliary line can be an oblique one. In order for this auxiliary line to belong to plane alpha, it must be concurrent with its lines, in this case R or S. Thus, we pass an arbitrary oblique line M concurrent with R and S at points R and S. Note that given the nature of the ramp plane, this auxiliary line can be represented anywhere. Determining the traces of the line M and knowing that the ramp plane has its traces parallel to the x-axis, plane alpha can be found. Now, before representing plane gamma, let's hide the straight line M from our 3D drawing to a better view of the plane's intersection. According to the data, plane oblique gamma can also be directly represented. Its representation can also be anywhere, since its intersection with the ramp plane will always be the same, whether the plane is represented more to the right or to the left. Having the two planes defined, its intersection can be carried out. That is, the intersection line I can be found. This line belongs simultaneously to both planes, remembering that for a line to belong to a plane defined by its traces, it must have the line traces over the respective plane traces. So, the frontal projection of trace point F of the straight line I must be simultaneously over the frontal plane traces, F of alpha and F of gamma, and there's only one possibility for this to happen, on the intersection of the two planes' frontal traces. Since point F is a frontal trace of the line I, that is a point belonging to the reference frontal plane, it does not have ordinate, and so F1 is at the x-axis. The same goes for the horizontal projections. The intersection straight line can now be fully defined by its two projections, I1 and I2. The straight line I is the intersection between planes alpha and gamma, because it contains 2 points that belong simultaneously to both planes.